This talk is about starting from scratch in a world where data is everything. Basically, if you're a startup and then you have a useful data set, how do you go about it? Because we know that data is a huge advantage. So very quickly, 2 words about me. I lead machine learning things at Instrumental. Before that, I worked from some known and unknown names. We're like 20 people to give you an idea of how big we are. And what we do is machine intelligence for factory lines. As you can see, we have this box that sits on the factory floor, takes pictures of things that are produced, and we have like an app available everywhere to analyze things that like the data we captured from the line. So mostly it's going to be about like to our domain, which is heavily image processing and using like modern AI and machine learning and deep learning techniques based on images. But I think a lot of those lessons kind of apply wider than just this domain. So let's dive into it. So let's say you want to make an AI startup, right? And one of the first key questions that you ask yourself, where do you get the data to build your models? And obviously, big companies like the Facebooks and Googles and Apples of the world have a lot of data and like a lot of resources of this juice and fuel, right, that you need to build a useful model. And as we all know, really, it's often not the algorithm or not the advantage in how many GPUs you have, but the quality of data that kind of powers the end result. So what chance do you have as a David against this Goliath of a data? And this talk is mostly like, what can you do? Where do you have an advantage? So some good news is not all data is equally useful. And a lot of times in practice, it's all about high quality, realistic, labeled data sets. And so the reason it's good news, right, is if you just look at first 2, high quality and realistic, you realize that a lot of the advantages that Google or Facebook or Apple could have suddenly disappears or significantly melts away. It's not enough to have a huge pile of all kinds of images from the internet. For a particular use case, you need high quality and things that are applicable to it. And just getting it out of the pile and finding representative images is hard. So here, like, the chances are suddenly like much more equalized. Still, how do you go about getting your own data? Let's talk about some options. So first, maybe you can find something from a public data set, from ImageNet or COCO, or like their NLP, Stanford NLP group has some, and there's many others. The typical problem with those is they're common and they're generic, and it's hard to find enough of a specialized domain. Say you're doing like a healthcare or like custom manufacturing. There's not a lot of public data from the factory lines out there. This is a highly coveted, protected information that you can't just like Google for. Maybe you can get your own data set and label it. For some domains it works. For a lot of the things, again, like healthcare and manufacturing, you can't just walk into a factory. You can't even buy this data. Sometimes, in some domains, you can partner. Like, for example, in healthcare, people are able to partner with hospitals and some other networks to get the initial data set. But say for us, we can't just walk in and ask Apple to sell us their data, right? This is not what they do. They have this mode of operation. Similarly, Foxconn or big contract manufacturers of the world, this is not what they would do. And there's different solutions. This is like one of those, how do you even jumpstart this? What our kind of stake on the ground here is useful data sets are collected because people pay you to give you data, not the other way around. And the way Google's and Facebook acquired massive data sets, it's not because they bought it. It's not like the way they invested in gathering it. They just received it as a nature of working their product. Well, to make this example concrete, here's our first product. Our first product is mostly made out of Legos. And it's just a bunch of a plastic box, some Lego, and a camera on top of it, which you can install on the factory floor. The camera will take a picture, will upload to the cloud, and show it to you. No machine learning, no AI, nothing. The question is, why would anyone buy this, right? Why would anyone pay us money to do this? It turns out that if you're building something in China, the only way to see what's going on there, what's like going on the factory floor, is to travel to China, go to the factory, and see what's going on. And this is what everyone does when they build anything, and much more so when you do your so-called development line. And even with this, just the fact that you can get those high-quality images from a well-calibrated camera without having to travel is a huge advantage. This means for a lot of the issues, your time to find the issue and resolve it goes from weeks to days, and sometimes hours. And our first customers just had this product. You couldn't charge much for it, but still, this is a way to get highly, highly realistic, controlled data set that you can play with. Okay, so now you got some data. Let's focus on the labeled portion of the data sets, because most of the modern algorithms need some kind of labels in order to be successful. So first stage is usually, at this point, is like ad hoc labeling. Does anyone often see posts like myths about machine learning or data science in their feeds? Okay, I see them a lot. And one of the myths that's constantly there is that more data is more insights, that machine learning only can apply big data, and you need a lot of data to train, and all of them are happily busting this myth. And they're absolutely correct. The techniques about transfer learning and augmentation are really, really, really powerful. I think a lot of you know what this is, but like transfer learning is a way to have a generic model and fine-tune it for your specific application, and augmentation is the way to synthesize data from a small data set to kind of artificially amplify your training set. At least in vision space, they work beautifully, and the typical numbers is you can start with like hundreds to thousands of images and train a model that's somewhat useful. It's not going to be the best model in the world, but it could be something that is useful in practice. And here's the main reason why. When we read papers, we have this expectation of human-level performance that is on those graphs. Those graphs, you probably can't read them, but this is like the typical graph that you always see about like ImageNet classification error going down over the years, or a speech recognition error, and the red line is human performance, and everyone understand you take it with a grain of salt, like this red line of classification, just one person who like did this for like a month and stuff like this. But this is what we think the human performance is. Some human that's attentive, knows what the task is, and a specialist. So the reality looks like this, right? It's someone in the factory, they have 5 to 10 seconds to perform inspections, and they need to inspect all of this pile of things, and much more than this. So full time for the whole day, you're like inspecting, and you have 5 seconds per inspection. You can imagine that at the end of it, or even in the middle of it, it's like the human operator that performs inspection is very tired. It's not like it's a high-paying job. So what you're comparing in practice is not the best possible human performance. And it opens up the ability to produce a model that has useful results. The next one is you can find use cases that are impractical to do with humans, and machines are much better at. The first feature that we launched that uses machine learning is so-called anomaly detection. You can select any region on any of the images of the units that you produce. This is a region on the left. And across hundreds and thousands and tens of thousands of units that you produce, we find things that are deviating. There are anomalies. In manufacturing, there's never good anomalies. An anomaly always means something bad. And if you have like a vague theory of what could be wrong, it's really a matter of drawing a region and waiting a couple of seconds to see this result. It's totally impractical to apply humans to this task, right? It's impractical to ask a human to review those thousands of images. And a model is worse than what a human would do if you ask him to do it. But just the sheer availability and how quickly this explorations it enables, deliver a very much useful value. So if you figured out some feature, some model you can train that creates a first feedback loop, which is with a better product, you can sell it, people more willing to give you data, right? So this is, you start accumulating data set. At some point, you need to figure out how to label it scalably. Previously, you labeled like hundreds. Anyway, like you can do this in any way. One person could do this in like spare time. So the easy part, the level easy of this, is if labeling does not require special knowledge, and it's kind of clear what the definitions are. In this case, there's a bunch of services that you can use to do this scalably, right? mturk, Crowdflyer, now it's called Figure 8, hire someone from Upwork, and things like this. Let's talk about level hardcore. Labeling requires expert opinion, experts are specialists, and they never agree with each other, which is a typical case for us. So in order to tell what's going on, this has to be a hardware expert understanding what exactly is wrong with the unit on the factory line. So you have an expert who's the only person who could deliver judgment on this. And the game is, how do you amplify their output? So one thing that turns out that works, you can pair an expert with a bunch of non-experts that do these things together, sit in a room next to each other while they're performing the task, and basically there's some training going on in real time, and the job of non-experts is to look through the images, and whenever they see something that's really in a tiny bit deviating, they ask the expert for opinion. And slowly, in time, they're like more confident in their choices, but it's crucial for them to be close to each other, and this is a way to amplify your experts maybe 2 to 3x, because the experts is your bottleneck. Then, you need a protocol for synchronizing expert opinion between each other. For us, at our scale, what worked best is it's okay for them to consult and to talk about what do different things they see mean, and maybe they're missing something. But for every particular defect or a class, probably and more generically, has an owner that determines the severity ranges. Like, what does it mean to be a showstopper issue versus just interesting versus somewhere in the middle? So those definitions evolve over time, but every class has an single expert owner that tracks and updates those definitions as we go. So this gives you the ability to amplify your labeling requiring expert like 2 to 3x. The more powerful one is use your machine learning models to accelerate labeling. Remember we had the feature about finding anomalies? We heavily use it for labeling. So you can see that this is actual screenshot of our interface. On top are the most anomalous issues, and then as you go down, it's less and less anomalous. And you can see on top, there's interesting things happening you need to label. But as you go down, it's more of like scrolling through pages and just making sure that nothing is going on. And this way, you can label extremely efficiently. So you basically spend a lot of time on the top, then less and less as you go down, and in the end, you're like, okay, everything that I didn't label is a no defect. Another feedback loop here, right? With a better model, sorting is better, so you can label faster, faster, and faster. Finally, last but not least, cookies are essential. And I don't mean this in a figurative sense, actual cookies, right? So when you perform labeling, having some short treats, some short incentive when you complete a unit of work to tag does not amplify the speed, but this is your retention mechanism. The benchmark is very simple. Experts in your company tell each other that you have good treats when you label data. Like, work towards that. This is the actual cookies that we use. Highly recommend. So with all of those optimizations, we get to something like 2.52K labels per person per hour, and in a team is like 5K per expert. This is significant, all right? So this means to label millions of images with 4 experts, you need like 50 hours, right? So finally, the final form of this is labeling happening as part of the product. I'll go quicker over this, but basically come up with the features that as you use the product you label. We have a feature where you can perform a monitor, and while setting this up, you can provide us feedback, which we use as labels and incorporate in training. Another example of this, just to talk about something not instrumental, in Dropbox Scanner, which is a little thing in Dropbox that lets you scan documents, it has a feature about adjusting the corners if it didn't detect them well. Naturally, this provides a perfect training data for extremely realistic cases. Small percentage of people will adjust, but this gives you a data to train the next generation of model that predicts better. This is the extremely powerful feedback loop. This is basically a recipe how to make a recipe, how to make the best model for anything. The more people use it, the better it becomes, the product is more useful, more people start using it. There's like a very powerful feedback loop. Okay, so this is almost all I had. A quick recap. You start with some proxy product to get you data, to get you in a game. Start with a small ad hoc labeling to build your first model, then launch into Scalable pipeline, and finally shoot for the product that produces human judgment as part of processing it. And we're somewhere here on this line. And yeah, I guess I had this obligatory slide about that we're hiring. The only thing I wanted to mention is we have positions in machine learning and don't require any ML background, and that we actually have those labels and we labeled it and built the infrastructure. So now it's like the perfect time to kind of waltz in and do cool machine learning models and deploy it quickly. It's like every company has this like time when it's like right for doing cool stuff. And I don't know how long this will take, hopefully for some time, but we'll see. This is it. Thank you.
We have time for a few questions. I have one. Okay. How does this relate to semi-supervised learning? Is that a word that you would use to describe what you were talking about?
So usually people mean by, like, semi-supervised learning is this big term, right, that has everywhere on the spectrum. And I think in one way that people use it, I think it's very applicable to our situation, is typically you have much more unlabeled data than labeled, right? So you have like millions of images that are just sitting there and a small number that you got through all of this pipeline. So methods that are able to use both, and there's certainly some of them out there. By the way, the whole talk is not too technical. If you're like interested in a technical part of it, please talk to me afterwards. But there are like very promising, interesting methods that combine the both, and it's an exciting research topic. Yeah.
So, which algorithms do you guys ultimately use in production to classify images into right category? Like, is it CNN-based kind of thing, or is it
right? Yes. So there's different settings for us. So yeah, we use deep learning and some pieces of the traditional computer vision and pre-processing, but there are two very separate tasks. One is detecting specific defects on the line, and another one is this anomaly detection or defect discovery, right? And the setting there is you have no idea what could happen, right? Like any kind of deviation is possible, and you need to find the ones that are like meaningful and semantic, and even humans who do this don't have, like, oftentimes are surprised at what they can find.
Yeah, so you talk about this intermediate stage of hiring or paying experts and bootstrapping, but you also said like a really poor model is actually not too bad, and you can bootstrap a crappy model because humans aren't that great at these things and not that consistent. So have you ever worked on with data where you could skip that intermediate, actually pay people to label and just go all the way to in product? You mentioned like Dropbox in product. It's very sparse data or very infrequent but very high quality. Have you ever seen it possible to really bootstrap without getting a big enough set of high quality?
It's an interesting question. I think when you're just starting a company, it's hard to skip it, because in order to get kind of the adoption, you need to go beyond your proxy product and to something that it actually does useful data, because this is usually the promise. I think if you have one use case and a product starting up, for other use cases, there's an opportunity to skip this intermediate stage. Because usually the data you collect, for example, the images from factories, you can imagine using them for many other things and many other products. So I think like once you got past kind of the first hurdle, the next one is only easier from that, and you can start taking shortcuts.